Problem 4. If a number is selected at random from a set of all 5-digit numbers in which the sum of the digits is equal to 43, what is the probability that the number will be divisible by 11? This being a probability problem, let's first identify the desired outcomes and the total number of outcomes. The desired outcome is numbers that are divisible by 11. So numbers divisible by 11. Over, and on the denominator, we have the total number of possible outcomes that we are choosing from. And this is the set of 5-digit numbers whose digit sum adds up to 43. So sum is equal to 43. Now, you sort of understand what's going on here. It might be a little confusing, but we have our problem here for more context. Anyway, so we need to essentially find how many numbers are divisible by 11 and how many 5 digits are there with a sum of 43 in order to figure out the final probability. So we're searching for two values here. Let's first start by looking at the total number of outcomes, which is how many 5-digit numbers have a digit sum of 43. So there's a 5-digit number, right? And we know that the biggest digit, so the digits range from 0 to 9, the biggest digit is 9. And we know that if all of these digits were to be 9s, 9 times 5 is equal to 45. So just exceeding over 43. And we want to take 2 away from this digit sum so that the digit sum of the actual 5-digit number is equal to 43. We can do this by keeping all 9s and subtracting 2 from one number, or keeping all 9s and then subtracting 1 from one number and then subtracting 1 from another number. So we have two different cases to look into here. The first case is when we have 4 9s, so 4 9s and 1 7, because taking away 2 from 1 digit that is 9 gives us the digit 7. And our second case here is having 3 9s and having 2 8s. These are the two different cases that we are looking into. Now our knowledge of word rearrangements comes in, because here we have to understand that there are 4 9s, 4 of the same digit. Now we can transform this problem into a word rearrangement problem by looking at it as a 5-letter word with 4 of the same letter. Now how would we do this? Well, it would be 5 factorial over 4 factorial, so divided by 4 factorial, times 1 factorial, which is equal to 5. So 5-digit numbers have a sum of 43, where there are 4 digits that are 9 and 1 digit that is 7. And let's do this for the second case as well. We have 5 factorial over 3 factorial times 2 factorial, which gives us 10. So there are 10 ways in which there is a 5-digit number with 3 9s and 2 8s. And here we are already eliminating all of the recounted possibilities. So we have 10 and 5 for each of these cases. Adding this together, we know that the denominator will be 15. So that we know that the denominator of this would already be 15. Now the only thing we have to do is find how many numbers are divisible by 11. Now what do? Well, we have to think about the divisibility rule of 11. The divisibility rule states that in a number, if you take the sum of all the odd places and even places, so basically the alternating digits, and take their individual sums, and then subtract these two values, and if that number is divisible by 11, then you get a number that is divisible by 11. For example, here this would be our odd place, even place, odd place, even place, and odd place. Remember, this is all in our divisibility rules video, so I will be linking that in the description down below if you are interested. So it's basically saying that if we take all of the O's and add them together, and take all of the E's and add them together, and then subtract E from O, and we get a number, n. And if n is divisible by 11, then this entire number is divisible by 11 as well. So we're trying to see how many of these 15 5-digit numbers fit into this scenario. Let's take a look at these two separate cases, case by case. So here, if we have 4 9s and 1 7, how can we arrange them so that the difference of their sums is the difference of the alternated digit sums is a multiple of 11? Well, we could have 99979, where 7 is on an even number, this is even, or 99997, where 7 is on a odd place. Now let's see if each of these work out. If we look at 9 plus 9 plus 9, which is 27, and we have 27 minus 9 plus 7, which is 16, we get 11. So this works. And if we have 1, 2, 3, so 9 plus 9 plus 7, which is equal to 25, and we have 25 minus 18, we see that this does not work. But there are two different, so 7 has to be on a even place. And there are two even places. 7 can be on this even place or this even place. So there are actually two. And here there are two ways. Now let's take a look at if there were 4 9s and 1 8 in this 5-digit number. Well, if this was the case, there would only be one possibility. The 9s would have to be in the odd places, and the 2 8s would have to be in the even places. And this will work because 9 plus 9 plus 9, that gives us 27. Minus 16, we have 11. So there is one way here. Now we add up 1 and 2, which gives us 3. So we know that the numerator, the number of numbers that are divisible by 11, is 3. So we have 3 out of 15. Now simplifying this, we have 1/5. So our final answer would be 1/5, or B.